Assalamualaikum and good morning. My name is Imran bin Muhamad Ghazali. Metric number CE190118. I'm going to explain about my final year project, MRC Control for Temperature Regulation of Dodo Processes. MRC is short for Model Reference Adaptive Control. Traditional dodo preparation takes a lot of effort, time and fresh ingredients to make. To generate the perfect texture and flavor of the dodo, it also takes painstaking labor, talent and the right method to obtain the consistency of the dodo. The traditional way of cooking dodo requires too much manual labor and energy, so to make it easier, the idea of using MRC control for temperature regulation is proposed. These are a few problems related to traditional dodo making that MRC will address. First of all, the traditional making of dodo requires too much workload because we have to monitor the fire every time to regulate the temperature. With the usage of MRC, the temperature will be regulated using the system, so there is not too much workload and the time wasted on the fire is less. Then we will also save cost because with the MRC system, there doesn't need too many workers in the factory or plant because the system will monitor it and make sure that the system is operating all based on the MRC. Then lastly, bad testing dodo will be less because the system is controlled by MRC. We will have better efficiency. These are the objectives for my project. First is to design a temperature measurement setup. Next is to develop a transfer function. Then to analyze the performance of MRC system. Finally, to compare the performance of MRC with a PID controller. These are the scope of study. First is to develop the setup to the temperature measurements for dodo plant. That is collecting the data for the parameters of MRC. After that, obtaining the mathematical model needed for transfer function of plant. Then designing the system of MRC in MATLAB Simulink. After that, analyzing the performance of MRC in dodo plant. And finally, to compare the performance of MRC with a PID controller. This is the project flowchart. First, to design the temperature measuring system. Then take the data during the dodo cooking process. Next, verify whether the data is suitable for MRC system or not. If not, we take the data in the dodo cooking process again. If yes, we can proceed to develop a transfer function. After that, simulate the result in MATLAB Simulink. Then collect the data on performance of the MRC. And lastly, compare the result with a PID controller. This is the temperature measurement system used to collect the initial data for the transfer function. For the data collection, a TS01 infrared sensor is used to monitor the reading of temperature for the dodo cooking process every 2 seconds and is stored in Arduino Cloud. This is the system identification toolbox. Is a MATLAB toolbox that will be used to obtain the transfer function using ARX method. Then this is the MRC circuit that is used for the MRC system and obtained in the MATLAB simulation. Okay, this is the result of the data collection. The first one is the data collection before filtering and after filtering. We need to filter the data to obtain an accurate transfer function. Okay, then this is the transfer function modeling using ARX method. We have here is the odd and even data. From the data, we see that the odd data have better best fits, so we are proceeding with the odd data in this simulation. Then this is the transfer function obtained. The transfer function is obtained in Z domain, but after entering the coding in MATLAB, we obtain it in the S domain. Then we conduct the open loop test for the transfer function to see whether we obtain the result correctly or not. Then we tested the MLC performance on different gain to obtain the best system. From the first test, we have a rise time of 150.94 seconds, settling time of 1422.147 seconds, and overshoot of 28.68. The second test have a rise time of 1419.916 seconds and settle time of 903.772 seconds with overshoot of 0.505. The third test have a rise time of 237.290 with a settling time of 632.495 and overshoot of 7.491%. The fourth test have a 381.64 seconds with a settling time of 900.870 seconds and overshoot of 20.816 seconds. And the final test with the fifth test, we have the rise time 207.784 seconds and the setting time 561.412 seconds and overshoot of 0.5. This is the result of the first test, and we can see it's quite unstable. The second test is stable, but it does not reach the reference model and is below the set point of 80 degrees Celsius. The third test is also unstable, and the fourth test is also unstable. The fifth test is the most stable one, so for this MLC system, we are proceeding with the result from the fifth test. This is the test from the fifth testing with a real-time simulation with the disturbance at 1 hour and a half here, because this is the time when the brown sugar is added. This is the compressor with PID controller. We can see that the MLC have better settling time and less overshoot and better rise time compared with PID. The rise time of MLC is 207.784 seconds, while PID reached a rise time of 334.933 seconds, and MLC have settling time which is 561.412 seconds, while PID have 1606.311 seconds. Lastly, overshoot of 0.5 for MLC and PID with 4.737% overshoot. Overall, MLC system is better compared to PID controller in terms of the rise time, settling time, and overshoot percentage. From the result shown, we can see that the waveform is stable and can be tested for real time for the MLC temperature regulation in Dodo plan. Thank you. Then I'm going to proceed to show the simulation. This is the simulation circuit, and this is the simulation result. Okay, this is the result of the simulation. Same as slide. Actually, both of the MRSC and PID is stable, but we can see that MRSC is better because of its faster rise time in reaching the 80 degrees set point and less overshoot, and faster reaching the settling time compared to the PID controller. Okay, that's all for my presentation. Thank you.